Hello, welcome to this ZKP panel represented by 3 platforms, ZK platforms, and 1 developer application. So we get to hear from both sides. I guess we can start with quick intros. I guess you've already heard from 3 of the platforms, but so quickly introduce yourself and also maybe a fun fact about your genesis story of ZKPs, how you discovered it, and why you got into it. We can go this way, maybe.
I can start. Yeah. Hello, I'm Adrian. Anoma is a unified architecture for full-stack decentralized applications. I mean, I gave the talk, so you should all know roughly how it works. So it's not just a ZK platform, it's more like a generalized architecture to build full-stack decentralized applications. Maybe fun thing how I got into the space is, I got into the space because I built private voting systems on Ethereum back in the day to help the Catalan people secede from the government. This was my thesis. And then I discovered ZKPs as a result, and then like Zcash, yeah.
Cool. Ali?
Eli Ben-Sasson from StarkWare. So by training, I'm a theoretical computer scientist, which is a kind of mathematician. And I've been doing this, I was a professor for many years doing research. And I was working on deploying proof systems before I learned about blockchain. And actually, when I was walking around trying to find use cases for them, this was in 2013, I chanced upon the Bitcoin conference in San Jose. That's where I got red-pilled. It was the most electrifying conference I was at. And since then, I was involved in it. So I'm one of the founders of Zcash, which is based on an academic paper we wrote, and StarkWare is based on other academic papers also. So it all came from math research for me.
Thanks, Ellie. Hi, guys. I'm Jane. I'm one of the co-founders and co-project leads of zkLend. So a little bit different from these guys. I'm actually part of a project that builds on top of StarkNet, which is a layer 2. And we are a lending protocol on StarkNet. So a little bit of background about myself. I guess I'm a Web 2 person by training. Worked in Web 2 for a really long time, but then started becoming a DeFi degen, and I guess started aping into different things and really fell in love with the space. So kind of given my training and my interest, decided to start a DeFi protocol with a couple of friends.
Hey everyone, and you just heard my talk, so I'll keep it nice and short. So Aleo, I'm the COO of Aleo, a platform for private applications. It's based on a research paper called ZKPs, which is short for Zero Knowledge Execution. So the way you can kind of think about it is Zcash with a little bit more functionality for smart contracts was the research called ZKPs. I personally learned about Zero Knowledge Proofs as a student. I was a student at Stanford several years ago, and that's when I was exposed to it through a very good professor, or the professor I had at the time.
Cool. Yeah, I'll give a quick intro. I'm Teck. I represent an organization called Gnosis Builders, which is a new organization that helps the new Gnosis chain grow their ecosystem. I also part of this new fund called Factor. It's a crypto fund. And previously, I was at a venture arm of Binance called Binance Labs. Yeah, so let's get going with the questions. First one is around architecture and design principles. I know that you guys already talked 30 minutes for the platform, but feel free to compress it into like 2-3 minutes and go maybe a little different direction around that. So I know that each platform has their own different architecture, and more importantly, as well, for the developer-facing abstraction, if you will, you all have different languages or DSLs, or what do you call it? What's the motivation principles behind those decisions? And I'll ask a separate question for Jane for the application side. Whoever wants to start. Yeah, go for it.
Go quickly first. So with Anoma, I think the big thing for us is that, practically speaking, developers need the ability to have transparent, shielded, and private state at the same time, and need to have the ability to write applications that sort of bridge across all of this in one unified system. So it's like, it's not that you can just build privacy-preserving applications on Anoma. You can, as a developer, pick sort of what your level of privacy preservation should be in your application, because different applications have different needs. So for that end, we're building Juvix, which I think out of all the languages we are building is probably the highest level language. Juvix can compile to transparent WASM. It can also compile to something called Vampire, which is an intermediate representation for polynomials that then can get extracted to different proof systems. I think eventually Vampire will be able to actually output Starks as well as Snarks. So Vampire is sort of Vampire, I think, is at the same level as Leo and Cairo, maybe. I'm not sure. But yeah, so people, if you want to write hardcore zero-knowledge proofs, use Vampire. If you want to write sort of high-level applications, eventually you'll be able to use Juvix to do that.
Cool. Ellie, you want to talk about Cairo?
Yeah, so we're often asked, so Cairo is a new programming language, and at its current state, it is harder to write things in Cairo than it is to write things in Solidity. And we're often asked, why didn't you go for this thing called zkEVM, which has been it's been a topic on Twitter recently. And I guess, we all know in technology of these things that sound like a good idea, but they don't quite work out. Google Glass, Facebook Coin, Facebook turning Web3 Meta. It sounds like a good idea, but then it doesn't work out to be a good idea. The issue with trying to do a zkEVM or to zk Solidity is that ultimately you won't get scale. And the reason you won't get scale is that the constraints that shaped Solidity are very different from the constraints that shape Stark systems, and by the way, also Snark systems. You have algebraic constraints that push you in a different direction. So we opted for getting maximal scale out of Starks, and this forced us to create a new, very minimal architecture that is what Cairo is. And that's our design. We need real scale, actually in production, and for that we need a minimalistic language in which you can craft anything you want, and we'll give you the scale when you actually need it.
Alex?
Yeah, so just to echo what Ellie said, I think, it's a question we get asked a lot too, where it's like, well, hey, why don't you just, there's plenty of languages out there, why don't you just plug into one of these languages? Why don't you let people write, Leo programs or, write Aleo programs in Solidity? And as Ellie pointed out, we're talking about two fundamentally different things. Like a zero-knowledge proof is a cryptographic object, right? Computers are kind of designed to do bitwise arithmetic, and it's very different than what you're doing inside, like Adrian pointed out, you're talking about polynomials and coding a program, et cetera. So these are apples and oranges. And again, as Ellie said, the challenge of shoehorning a model like the EVM into the model of a ZK proof is hard and comes with a lot of performance overhead. So we also chose to implement basically our own stack. And the advantage of that is you get a little bit more efficiency. And so the way it works in Aleo is we have Leo, which is a high-level language. And the idea is for it to look like and be familiar to anyone who's written JavaScript or maybe Rust, and so you get somewhat of a familiar look and feel. And then Leo compiles down to an intermediate representation, similar to Vampire, where that is a little bit closer to the R1CS, which is the ultimate target, right? And the idea of the intermediate representation, actually many people in this room may or may not know that Solidity actually has an intermediate representation called EUL, and EUL is closer to the EVM bytecode than just the Solidity code. So a lot of people who are interested in optimizing smart contracts will just write in EUL as opposed to writing in Solidity, right? So AVM, in our model, the equivalent is the AVM, and so you can write AVM instructions directly, and then those AVM instructions compile down into R1CS, which is what, basically the logic of your program, and from which you can synthesize proofs from. So that's kind of how it works end to end. And the zkEVM space is very fascinating. And again, I think if we just looked at the history of zero-knowledge proofs and the development over time, you've seen a lot of things get more efficient. I think hardware acceleration potentially will have a lot to do with all of our different systems. But in general, it's much, much more efficient to build a purpose-built compiler architecture for this particular use case as opposed to shoehorning in something that wasn't really built for it.
Yeah, go for it.
So this is maybe not obvious to everyone, but I think sort of in the past, the space was driven by distributed systems people and then by cryptographers, and I think the future is going to be driven by compiler people. once we get into sort of this level, most of this problem becomes a compiler stack design problem on like how do you hook these different components into each other in a coherent fashion. So I think the PLT people will, like in the next 5 years, love blockchains.
So Jane, you're coming from the developer perspective. Obviously, zkLend is on StarkNet. So I want to maybe talk about your consideration when you picked out StarkNet. Maybe that's the only thing that's production level at that point, but talk about your considerations when you pick a ZK platform.
Yeah, definitely. I think these guys talked a lot about, obviously, the technological, differences when it comes to L2s or their respective L1s. But I think for us specifically, the tech was probably 30% of it when we decided to build on StarkNet. At the time, we decided to build it at the end of last year, so it was still a relatively new ecosystem. I think that was like right when mainnet was coming around. Couldn't tell you right then and there, like we knew exactly everything that was going to happen 6 months down the line. We knew that the tech was arguably superior because we wanted to go into L2s with ZK rollups and optimistic rollups, and we felt that StarkNet was kind of the farthest along in the development journey. But I would say the other 60% of it comes down to the team and the ecosystem. First off, on the team, because the StarkWare guys have built multiple products in the past, including StarkX. So for those of you who heard Ellie's talk, StarkX came first, and they had powered, isolated L2s. I guess that's how I would characterize it. But for the likes of Diversify and SoRare and Immutable X. So for us, we knew that the team had a track record of building. This definitely came to fruition because now that I think about the state of StarkNet, things like account abstraction and recursion were not like top of mind. In fact, I probably didn't even understand it fully if you asked me at some point in November what they were. But now they are front and center of StarkNet, and they are parts of the differentiation for the network. So I would say team was a huge part of our decision. And then finally, the third one is ecosystem. StarkNet ecosystem is actually pretty small if you compare it with the other guys. But if you look a little bit deeper, you'll realize that the folks are actually quite different. Because the language, everyone codes in Cairo, it's more difficult because you have less tooling, and it's arguably a little bit more frustrating. But at the same time, people who are developing on StarkNet are not there to kind of copy pasta what's already done on Solidity, because why would they do that, right? Why would they bother to learn a new language? So then you draw in a new crowd of developers, ones who want to build games that are not just like, about farming, right? They want to build like real games that gamers will enjoy. There's another project that's really fun called Brick. You can like build sets of like images or NFTs with bricks. And so I would say the community really thinks outside the box. And that's another reason of what drew us to StarkNet.
Cool, thanks.
I want Jane to answer all the questions.
Right, you probably paid her before this. But let's move on to scalability. I think ZKPs have proven, obviously with StarkNet, there are two models of scalability to scale layer ones. On layer twos, ZK rollups and optimistic rollups. And all of you can comment on it. I guess you guys have L1s that would potentially want to scale later on, but StarkNet is already kind of live to some extent. Maybe Ellie, you can comment about the differences between ZK, like the trade-offs between ZK rollups versus the optimistic model of rollups.
Tricky question. Okay. I'll try to be political here. First of all, when you choose a layer 2, check how production ready is the technology. Is the core security features underlying the security as an L2? I mean, remember, what does L2 mean? It means that your security lies only on assumptions on Ethereum, which means that all parts needed for your L2 to work, be it fraud proofs in the optimistic rollup case or validity proofs, are actually turned on. Now, I promise you that for StarkNet and StarkX systems, they are from the start to end. Check with other L2s before you deploy whether the core technology that is securing your users' assets is actually turned on as intended.
But given that, let's say they
Given
fully
that,
built out
now,
fraud proofs.
if we assume that, which
Right.
is a big assumption, and if you look in the fine print, you'll see that it's not always the case. let's go beyond that. Let's suppose that all of them are actually deploying the technology they intend to. Well, there's a big difference between validity and optimistic rollups. Optimistic rollups require all witness data to be rolled up. Okay, I'll give an extreme example. Suppose you want to process a block of, let's say, DYDX transactions that involve thousands of Oracle price feeds. Now, if you do this with an optimistic rollup, you're going to need to upload onto Ethereum all of the signatures on the price feeds, because that is needed. If you invoke the core technology of fraud proofing, you need that in order to have an arbitration process. On StarkNet, you don't need that. You only need to upload to Ethereum the diff between the start and end state of the system. So all of the witness data, all of the signatures are not needed. So because of these things, the future proofness, the ability to scale, is much greater with validity rollups than with optimistic rollups.
Maybe I can give the politically contentious answer here that Ellie didn't want to give, which is that I think so far none of the optimistic rollups have deployed like in production fraud proofs that are callable by anyone, which means that, I alluded to this in my talk, like it's a single operated database. It's like a single key that operates effectively in an exchange. You placing a tremendous amount of trust with regards to your assets into the optimistic rollups. I think long term, I'm actually not completely convinced that you need L2s. I think we should be building many more blockchains and have many more L1s that are interoperable with each other. But I'm personally much more bullish on ZK rollups. I think the big appeal here why optimistic rollups became a thing is because one thing you cannot do on a ZK rollup, unless you assume the ZK EVM eventually happens, is that you sort of do copy and paste from mainnet Ethereum to your optimistic to your rollup, right? And with optimistic rollups, you can sort of hope that in the future, theoretically, you can just copy and paste the code and you get perfect fraud proofs. Albeit I would say generalized fraud proofs on Ethereum, we've been trying for like 4 or 5 years now. It started with Trubit in 2018. They are hard. And it's still an open question to me whether we can make them work.
Okay.
Yeah, and I guess just quickly to weigh in, I'm going to take maybe the answer a slightly different direction. Again, so we're not an L2 on Ethereum, so I think I have a slightly different perspective. I mean, I think maybe in the future, I think there's aspects of both approaches that are desirable. I mean, if you think about Bitcoin, well, what was the real innovation of Bitcoin? It wasn't cryptography, right? It was this insight that you could introduce this economic incentive and then therefore align all the actors in the system together, right? And that's kind of what optimistic rollups, purport to do. Again, these guys mentioned very real challenges that are facing them today. But I think in the future, we talk about systems of modular blockchains potentially, and at different layers, you may have different parts that are secured by zero knowledge proof, and others that maybe you're incentivizing the actors to do something in the right way based on economic incentives. And so I kind of view the future to be a blend of these two approaches, because some things are very, very hard to secure using a zero knowledge proof. Like, for example, like what is a fair sequencing? Like, how do you ensure fair sequencing on a roll up? And okay, maybe that's like a good use case for like an optimistic thing where you're like, okay, we have some concept of fair, and then if someone deviates from that, maybe they're slashed or something. And so this is like, it sounds a little bit closer to an optimistic roll up than a ZK roll up, but then you can use the zero knowledge proof to ensure the security of the transaction and compress effectively the information in the way that Ellie was talking about. So I think the future, honestly, 5 years from now, I think we won't be talking about ZK rollups, optimistic rollups. We'll just be talking about some concept of a rollup, or maybe even just of a modular blockchain, and we won't kind of draw this distinction.
I just want to comment that since there's no optimistic rollup folks here, they can defend themselves. But what you're describing is an intermediate state, but their end state supposedly will have fraud proofs, will have the exit game that works, somewhat nicely. And then, but what I'm alluding to is like, is there a trade-off when you do ZK rollups? Validity proofs where it's less generalizable than optimistic rollup, which is just replaying, or just like rolling up transactions and using fraud proofs to roll back. I mean, is there any constraints around generalizability on the complexity of the things you can write? It's a circuits you can produce.
So I think you are better suited to answer this, but I think another difference is, which will persist long term, that in an optimistic case, you have this challenge. So you always hope that someone has an economic incentive to actually figure out whether there was fraud. that is so you have an economic game similar to like a commit reveal kind of system where like someone has to be watching, and if there's fraud, then they have to submit. In a ZK rollup, you don't have this. So like in my mind, the main trade-off will always be like, do you believe the economics over the cryptography? Because the cryptography may be broken too.
Right. But is there a constraint on the generalizability?
I'm not aware of any constraint that is, or any, in the long term or the near term, in which optimistic rollups give you a better trade-off. It was claimed, again, on crypto Twitter, but this is, evidently not supported by facts, that midterm, or it would be easier and hence faster to roll out the technology that is optimistic rollups. But the facts are, and as Adrian pointed out, the technology of StarkNet is in production as intended for over a year, and that of, I'm quoting him, that of the optimistic rollups is not yet turned on in any system. So the facts are that even this one advantage that some people have said is supposed to be the advantage of optimistic rollups doesn't hold. So I don't see any advantages.
Yeah,
Okay.
yeah, and I think, I guess I'll say two things. First, just as an aside, it's kind of funny how in crypto I just rediscover the same thing multiple times. So, Adrian a minute ago mentioned TrueBit, which was this kind of, it's like an older version of optimistic rollup, and that, kind of the thing about TrueBit, which everyone focused on, was this concept of the verifier's dilemma, where it's like, okay, is there actually an economic incentive to find these deviations from the rules? And that itself came from, people who consider like, okay, well, should our full nodes on Ethereum actually going to replay everything, or are they just going to take the other node's word for it, right? So anyway, it's just, if you go back in the history of the space, I think you'll find that we constantly are rediscovering and giving new names to the same things and the same concepts.
It was called verifiable computing way back, and TrueBit is through economic incentive, and then using ZK is using
right, but none of these were ever deployed in production.
Right.
Yeah.
Agree.
And I think the other thing that I just wanted to say is, there's this concept in the optimistic rollup case, like Ellie was saying, you're like, okay, well, it's easier, it's faster, you can just port everything over. But I don't know if that, I guess from a developer ergonomics perspective, I think that's arguably the biggest draw, right? Because you can just literally, at least in theory, port over exactly what you wrote over in this model. But I think other than that, there's many other advantages of ZK rollup, especially around security, that I think, especially, look, just the last 2 days, there's been 2 hacks of how many millions of dollars, right? So this concept of security, I think a lot of people overlook because they want to do something easy and fast. And, Ellie is the cryptographer here. He can tell you, doing things easy and fast is a good way to get in a lot of trouble. And I think having these cryptographic security models is a much more foolproof way to go, especially when you're talking about potentially systems that are going to secure millions and millions and millions of dollars.
All right. Let's move on to privacy, which is the domain of Aleo and perhaps Anoma, and maybe StarkNet as well, maybe. But privacy. No, yes. Well, we'll talk later. Yeah. Privacy is a very elegant solution to censorship resistance, MBV resistance, data sovereignty, and all those things. And it's kind of overlooked right now. Nobody cares about privacy, but I think privacy is going to come to the fore very soon in this market due to all these things I talked about. So I guess starting maybe with Anoma, talk about your privacy model, why privacy is not widely prevalent today, and why you think it's a product market fit very soon or in the near future.
Yeah, so I'll start with why privacy-preserving tech really hasn't taken off that much. It's really new. This is really the easy answer to this. It's like Zcash came out 2015, something like this. Computing approved still took 8 gigs of RAM. You had to run it on a Linux box, and Sapling came around in like 2017, 2018 with the upgrade. All of a sudden, it was capable of running this on a mobile phone, on any modern mobile device. So tech is really just new, and I think we're just hitting sort of the beginning of the exponential growth. This tech is going to get exponentially better. It's going to get way easier to write circuits. I mean, we're all working on languages that either compile to circuits or that can be used to write the underlying circuits. So all of this will make it way easier going forward to build this tech. And then secondly, I think historically, we really haven't had the need for a lot of privacy-preserving tech because institutions were capable, and I think we generally, at least in the Western world, we felt well protected by institutions. That institutional trust is eroding really quickly, and all of a sudden people start caring about, does privacy actually matter? And when it comes like to the US and abortion rights, like all of a sudden period tracking apps are like, well, should we be using these things or can they be subpoenaed? And I think this like, that case is probably going to be the single biggest trigger point for privacy preserving tech in the mainstream, because all of a sudden people are starting to realize that, something that was legal 5 years ago may now, like my data is still around, but now it's being turned into something illegal, and people are going to use my old data to prosecute me. And so I think the intersection of the tech getting exponentially better at this point in time and the use case becoming very much clearer, where it's like people really need to start defending against failing institutions and erosion of privacy rights, is going to like lead to a very cool intersection in the next couple of years on like really cool privacy preserving tech.
Cool. Maybe Alex, you want to?
Oh, yeah, change up the order a little bit. Yeah, sure. So I don't like to frame it anymore I agree with what Adrian said, but I have found in my experience that framing it as you should care about privacy because all of these abstract things is a hard way to get people to change their behavior. Because I think it's just like, there's some other analogies in behavioral economics, but I guess at a high level, like you really need to provide a tangible benefit to somebody. And the way like I like to present it is, okay, what can this technology enable that you can't do in another context? And I think like in Web3, and Jane mentioned this earlier, there's like different types of gaming of like classes of games that you can kind of only really do in the Web3 context if you hide some information using a zero knowledge proof. And that's cool. That's a capability that you didn't have before that now you have. My favorite use case personally for zero knowledge cryptography is this concept of self-sovereign identity, where it's like, I want to prove to you that I have some kind of verifiable credential without you knowing everything else about me. Right? And I think that, as the world moves more and more online and is more and more digital, I think, people will see the obvious utility for something like that. And really, it's not possible to create that system without something like zero knowledge proof. So I really like to focus on the utility of like, what is having the privacy give you? And then if push comes to shove, if I am talking about the value of privacy, I don't even like to use the term privacy. I like to say security, right? Because like privacy is kind of a different way of saying like you're securing some information from other people's knowledge, right? I mean, that's kind of a silly way to think of it, but I think people, if you say security in general, people are like, oh, I definitely want security. If you say privacy, people are like, that sounds like a good thing. Maybe I should think about that.
Cool. Ali, you want to comment a little bit about maybe?
Yeah, I root for Anoma and Aleo, and I hope that bringing privacy-preserving technology to blockchain will work. My experience through Zcash and also the strategic decisions we made in StarkWare point to not focusing on privacy first. I would say two reasons. First, the sad reality is that people talk about privacy. There's this paradox. We talk about privacy, but we don't act so much on it. That's a reality. And the second problem, which Adrian touched upon, is that the biggest friction and challenge in, let's say, doing things privacy preserving, for instance, in Zcash, is I think all of the integration with the rest of the world. So exchanges have a very hard time dealing with shielded transactions. Users have a very hard time. There are hardly any wallets, and certainly not good ones and easy to use ones, if you want to, let's say, generate a snark for a Zcash transaction. So all of this together just drove us to say, let's focus on scale first. So, but I'm rooting and applauding those who are trying to change it.
And I think that you're absolutely right. I think it's hard for people generally to grasp like the utility of it, but I think it is important to try as leaders in this industry to try and make this the standard. To your point about Coinbase, it's like it's difficult for the world to adapt to these privacy preserving technologies like shielded transactions. And I think we're at kind of a unique crossroads in this moment where we're defining the future of finance, I think. And I think we have a choice to build it in a way that empowers people and maintains there's some sense of digital liberty. I think the natural path is to just go with something that everyone just is going to agree to. And I think obviously, certainly regulators prefer everything to be transparent and easy. But I think there's a lot of reasons, and Adrian, you talked about people who are in the third world. Like it's not always clear that a regulator or a government or just some other third party has your best interest at heart. And I think, I think all of us are philosophically aligned on this point that I think it's important to think about as we architect these digital systems that may be around for the next 50 or 100 years.
Yeah,
I
I
would
guess
agree,
I
yeah.
want to share like a user's perspective, or from the retail user perspective, why privacy is important, right? Because, for example, for our product, we actually have a product for retail users and institutional users. But how do we actually get institutional users on board? It's great to be like, okay, we want to bring in institutional adoption. Like, that sounds great and all, but like, how do you actually incentivize these guys to use it? It's not going to be showing up all your transactions on chain. Like, maybe crypto native institutions might be open to it. And I think the crowd is there for it, right? Because you think about 3 Arrows, if you think about Celsius, you think about like, okay, if everything happened on chain, then I would be able to track it. But at the same time, like that's not what large institutions want. And so privacy preserving features in my mind is a must. Now the other part of it is like, again, it all sounds great, but when it comes down to the actual implementation, right? Like, so I guess if I want to trade something and I don't want other people to know exactly how much or when I'm trading, I'm able to kind of like use, like, let's just say Anoma to mask this transaction. But when it comes to lending protocols, it's actually not as simple as that. It's not like, I want to borrow $3 million. I don't want anyone to find out. I can just use Anoma and that's it. Like, that's not the way it works. Because if that were to happen, there's actually like interest bearing components in my protocol where I actually need to account for this. So I would say, in theory, it all sounds great, but there's still a long way to implementation to actually see it happen in protocols. And I think that's exactly what we were talking about earlier.
Yeah, absolutely. But maybe to like on whether scale versus privacy first, I think the real challenge to get actual mass adoption in the space, like outside of like, we are like a magic bubble. Like everyone in this room is like in the magic bubble. This is not real world adoption, right? Like real world adoption is your parents using it, maybe your grandparents using it. This is what real world adoption looks like. People that don't know the tech and don't care, that just want to have payments or something like this. And I think the single biggest hurdle there is going to be that no sane government is ever going to allow their financial system to be a transparent system, readable by anyone, simply because all of a sudden you have to worry about attack vectors like North Korea scraping your entire financial system. And so I think like in order to gain mass adoption, we both need scale, but we also need privacy. And I think we need both of them, otherwise we're not going to get to mass adoption.
If I could just mention that, so even though I was saying that at StarkWare, we're not, focusing on privacy. If someone builds a layer 2 like a dedicated StarkX system or a layer 3, which is layer 2 off of StarkNet, then the operator of that system, so the end users reveal basically all of their information to the operator, but the operator has privacy and shielding from the rest of the layer 1 or layer 2. This is already the case with our StarkX systems. So you get sort of half privacy or privacy for the institution running it, which is, I think, also what Jane was referring to a little bit. So that's also...
But the operator can MBV those
Yes.
transactions, yeah.
Well, the operator, yes, but this is true also with conventional world
Sure.
systems, yeah.
Yeah.
Or
Conventional exchanges, right? Like
Yeah,
sure, yeah.
Basic.
Yeah, but trust
We
me,
should be
right?
building
You have
better
to-
systems. We should not forget.
Agreed. I mean, you can encrypt the transactions and MBV is gone. But anyways, let's move on in the interest of time. I want to go back to the zkEVM topic a little bit around, one of the great strengths of open systems like blockchains is that it's by definition composable and interoperable, and also more important, like for applications like zkLend, portable, right? You write once, deploy to multiple EVM compatible chains. So talk about composability within your ecosystem and then outside the ecosystem. Can you achieve composability, portability, all those things? Can you cross-compile things and things of that nature?
Yeah, I think this is one of the big reasons why we've been focusing on building out an entire compiler stack to support this. Because you could, for example, implement an EVM backend to Juvix, and then the output just becomes EVM bytecode, right? By building high-level languages, we can build abstractions into those languages that are platform agnostic. This is still very early, and this I think is going to make things more composable over time, as in you can move different applications between different systems. This is also true for like proof systems. I'm not convinced that like different applications want Starks and different ones want Snarks. And you probably don't want to define this in like the specific program that you write. You'd rather say like a compiler flag, I want a Stark proof out of this instead of a Snark proof, right? So I think this is why compiler stacks are going to be so tremendously important to make the entire ecosystem composable.
I prefer the Jane answers.
Yeah, I guess I have a little bit of a controversial view around this, which is composability. I think, dApps do want to get on as many chains as possible. There are some strategies where they want to capture as many users as possible. But in a world where we actually believe that things are going to go multi-chain, I guess I struggle a little bit to understand why dApps would try to go onto every different network if the bridging process is as seamless as it should be. So I don't have a long answer to this, but it's something I guess I'm still personally struggling with, because I see a lot of protocols, they're like, I'm going to port over here, I'm going to port over here to capture more of the audience. But at the end of the day, if we think that indeed in the future everyone is going to be able to move, let's just say easily, from Anoma to StarkNet L2 to L3 and then back onto ETH L1, then I struggle to see why you need to be present on every layer.
I just comment on that. Like, Vitalik did posted something earlier this year about he believes that it's a multi-chain world but not a cross-chain world because of the security issues. But what about composability, where you're building on top of other protocols? Is that important? Probably important for DeFi protocols, right? Where you don't have to reinvent the wheel from the ground up. So I guess Stark, maybe you can comment because she's on StarkWare.
Well, I just think that, yes, you can have composability. First of all, like within StarkNet, you'll definitely have composability between the various layer 2s and layer 3s. We already, 2 years ago, wrote a blog post about how you can have cross L2 composability using Ethereum and other techniques. And these will definitely happen. And of course, you can have bridges with all the, advantages and disadvantages. So I think the future is bright for composability also on L2s.
Yeah, and I also think, the future, there's a lot of ways where it could play out. To Jane's point, there's going to be, the emphasis is going to be on bridges across what layers. Is it going to be just L1s and people are going to bridge them? Or are there going to be, composability across L2? I think it's a little uncertain how it's going to play out. One thing I do think is zero-knowledge proofs and zero-knowledge cryptography is a powerful tool for bridging, potentially. If you look at some of the work that's being done on the chains that have these basically super light clients where they use recursive proofs to just compress everything down. It's in some sense a more secure infrastructure to enable bridging, and we certainly need more secure infrastructure for bridging given the events of the last week and prior months. But back to, I think, composability within an ecosystem. One of the things that I'm particularly excited about for Aleo that I don't think has been done before is we have this concept in Aleo of a program registry where you can import basically libraries or circuits that other people have written directly into your program. And it's always shocked me that something like this hasn't existed in Web3 before, where it's like, if you're a Solidity dev, you're like, okay, what's the library I need to import to, make sure I don't overflow an integer? And you're like, well, you don't import a library, you just copy and paste all of this code from SafeMath into your contract, right? And so every other programming paradigm or language ecosystem I can think of has this concept of a library that you can say, hey, import this, import this, import this. And you don't have to worry about, okay, I accidentally left off the last line when I copy pasted this. And so I think that's kind of cool. It ensures there's more security, there's more composability within programs and within circuits, and you could potentially have circuits compiling into things that many people worked on. And then it also opens up the opportunity, because this is in the Web3 environment, like you can have microtransactions effectively and pay authors of these libraries like SafeMath, which really there's no economic incentive to write this, really. Like, it's just a public good, but you can potentially introduce, microtransactions like, okay, every library that got imported, you're paying maybe a small, very tiny, non-noticeable fee to these people to help sustain these critical pieces of infrastructure. So for us, that's like one of the things that we're really excited about and focused on at Aleo.
I think an important thing that most people don't realize actually about the composability of sort of privacy-preserving applications is that if you want to have shared state, so if you want to have something if you want to have shared state, you can't really do this privately because the person that generates the proof needs to have access to all the state. So this is like an actual real-world limitation right now I think in all our models actually, whether it's Tiger for us as a unified execution environment or the Aleo VM, or I guess in StarkNet this is also true, that you can't really have private Uniswaps. This is going to go away eventually, though. We're going to get to a point where fully homomorphic encryption is going to be good enough that we can actually make this work. In practice, this is probably maybe 5-10 years, I don't know,
Or
some
even-
time away. But
Or even constructions with MPC, right? So
Yeah.
MPC and FHE, you can combine these things. And this is why I said in my last talk, this is the beginning of the beginning of the beginning. Like, this is such an exciting time to be in the space. And I think you guys, I think it's great that you're all here.
Okay, last question quickly, we're running out of time. Looking towards the future, what areas of ZKP research or ZKP development are you excited about, and what would unlock new stuff? New use cases and everything
better
else.
languages to write circuits in. And I think and I hope sort of like Vampire is like not specific to Anoma, just a way to encode polynomials for proof systems. I'm pretty excited about this because it will give people the ability to like much more easily write things like Zcash or the StarkNet circuit or the Aleo circuit or the Tiger circuit. We need way better tooling to write circuits in. Not to build on top of circuits, but to write the underlying circuits, because currently really it's still, you like hand write constraints in Rust and it sucks.
I agree. The programming languages, new models for creating these proof systems. We're probably next week going to turn on recursion. We just posted the paper, a math paper on using elliptic curves for better Starks. So there's a lot of exciting things that's going to happen.
I'll tweak the question a little bit. Talk about things I'm most excited to see ZK proofs apply onto. So want to see a lot more real-world use cases. I mean, it doesn't necessarily need to be transactions on the street, but like voting systems, right? I think Adrian mentioned that, medical records. I want to see us kind of move away from financial transactions, even though I'm in DeFi, but I want us to think about things that are more applicable to people besides finance.
Yeah, and just to piggyback quickly on what Jane said, one of the cool things about this paradigm when you're computing something off-chain and verifying it on-chain is the runtime becomes unlimited. So you could do like ML on medical data and not be constrained by the gas model of the EVM, which I think is really cool and a nuanced point that not a lot of people realize. For me, the thing that I'm most excited about is hardware acceleration for snarks. I think, I remember a time when if you use the internet to load an HTTPS website took noticeably longer. Right, and it really took Intel to, implement at low levels a set of instructions at the hardware level for that, for AES specifically, an encryption algorithm for that time in human terms to really go down significantly. And I think ZK snarks and Starks and all of these zero knowledge proof systems there's an opportunity to optimize the level of hardware to get things to the point where today we're like, oh man, this is just completely impractical, but hardware acceleration potentially holds 100 or 1,000x. Gain in terms of efficiency. And so I'm really excited about that. And so that I'm wearing a shirt called Z-Prize, or with the Z-Prize logo. So Adrian and I are both participants in this initiative, which is all about incentivizing hardware acceleration for snarks. So it's an $8 million initiative to try and get people to do this work and then open source it for the good of everybody.
Cool. I think we're out of time. Thank you so much, panelists.
Thank you.
Thank you.
Thank you.
Thank you.